Welcome back to this series on building a simple image viewing and image processing application in Rust using egui. And I did a little bit of stuff off camera, namely fixing how the panning works. So you can zoom in now and it correctly actually moves the image. You can still zoom out. And when we run the Sobel filter, it actually does the correct calculation. And it was the correct calculation. These calculations we did were correct, but the way we combined them wasn't correct. So we actually have to square them all and then add them and then take the square root. All right, so let's try to run it again actually. And you will notice something. So when I run the operation, it's basically instant, but it's not a given that any operation we make is going to be instant. And in general, we might want to move heavy operations to like a background thread, so the UI is still responsive, and we can actually simulate that. So I think we need to do something like this and like this. We can simulate what would happen if we have a very heavy operation. So let's just do thread sleep, and we can say duration from seconds, and let's sleep for 3 seconds. Okay, and I think this just takes an integer. So let's try to run that, and we can see what will happen. So I run the operation, and now I cannot do anything. The UI is completely blocked because of this artificial thing we put in, but the operation could take a long time to finish. So it's not really so nice that the UI is blocking. So let's actually keep it for now. So we simulate that it's actually something that takes a long time to run. So what we want to do is use what did I do? Right, I don't need to use this. I can just do like that. So what we want to do is to use threading to put the operation on a background thread. And we also, so let's say we make a new function that we call run Sobel thread. Okay. So we go up here and we make a new function that's called run Sobel thread. And let's do all of this stuff again. And I don't think we can share this context to other threads. So what we'd want to do is copy the data we need, send it to the background thread, get the result back, and then use the context to actually upload it to the GPU and all that stuff. Let's try to make a simple function that runs in a background thread like so. And maybe we can print something, print like running on a background thread. And then we could even put in the sleep. Let's just copy this, put in 3 seconds sleep. And then we can return 3, because I want to see what happens when you return something. So this starts a thread. Okay, and then you can say, let's wait for it to finish. That's join. And it's actually returning something. So let's say result is that. And what is the result? It is a result type of an integer or something else. So let's just unwrap it for now. And then we'll get out the number here. So here we'll get out the 3 by doing this. But join waits until the thread is finished. So it will actually wait the full 3 seconds. What we want to do instead is to periodically check if the thread is finished. That means we need to return immediately after we spawn the thread. And actually, why don't we make this like even longer? Make it 10 seconds. We need to periodically check the handle, and only when it's actually finished, we call join. So what you can do is you can say is finished. And if that returns true, then we will join to wait until it's fully finished and get out the result. That way we don't have to wait very long. But to check the handle periodically, we probably have to store it. So let's say background job handle. That's going to be an option because we don't always have a background job running. And what is the type of this? It is a join handle of T. Okay, so it has a generic type, and I'm not sure how we're going to handle that. But let's just do, it should be here, right? So join handle, and we'll say that for now it's always an integer. And when we create the application, no, that's fine. What is it? Never read. Okay. So what we're going to do now is we're going to say self dot background job handle, and we can say replace with the handle. And that's all right. So like this. And this, I think, also returns something. So we can just explicitly say we ignore that. So really this function should not be called run, it should be called start. Call it start instead. And then what we can do here in the UI, we can say if, the UI code, we can say if self.background job is sum, then we're going to check check background job. Okay, let's do something like that. Check background job, check immutable self, and that's right. So we'll say, okay, if this background job handle is actually finished, right. So let's just do a check like this, if let sum handle, just so we're sure that is always called. Well, so if we call it like in the wrong context when there's no job, we don't like accidentally unwrap something or anything like that. So anyway, so if the handle is finished, then we are going to say the result is handle.join, and we'll just assume that it succeeds. I'm not sure in what case it would fail. And maybe, can I do take? What happens if you take the value of only if the predicate? Okay, so we can say take if the handle is finished. Okay, that should work. So now if the handle is finished, we actually just take ownership of it, and let me see what it actually returns. It does return an option. What if the predicate was the value? Okay. So at this point we know it's finished, so we don't need to check on that. We can just say let the result be handled join unwrap. And then we can say the result was result. All right. So let's just try to get that running. So I press this button, it prints, it's running on a background thread. We now have to wait for 10 seconds, maybe 10 seconds is a bit too long. But should be there at any moment. Okay, So finally it finished and it says the result was 3. So actually we forgot to test the very thing that we're supposed to verify. Let's try to run again with 5 seconds. Image. Now it's running on background thread. We can still interact with the UI, no problem. And then when the result is done, we get it back. All right. Let's see. Now actually try to do the thing we wanted to do. And what do we want to do? Let's get rid of the context because I don't think we need that to start the thread. So let's do like this. And if we check out this function, we take actually 2 copies of the image. So why don't we just like take 1 copy? Let's take 1 copy and okay, so we also cannot really start anything if we don't have the image being something. Self.image. And that's fine that we have to copy it. So we take a copy and then this function now, instead of the context, let's say that let's keep it for reference. I'm gonna copy it. Just copy paste it for now. Copy paste it. Did I do that correctly? No, I'm missing. And so let's say run to job, and we will need the reference copy, and it's going to be a gray image. So we're going to say image gray image, and we don't need this one anymore, and we don't need this and this, and we're not going to copy to the image. We'll do that later. And that's fine, that's fine. Okay, so this should be reference copy, and this one we can say the reference copy. Let us clone it. Okay. Now everything should work. Let me format it. Didn't really want to format it. Wonder why. Try to build it. Probably there's something wrong. Yes. All right. There is a bracket. No. We need an extra bracket. No. We need an extra bracket here. I don't know what I did wrong, but let's do it. Duplicate definitions of this runs a will. Okay, I think I copied it too many times. That's the issue. Okay, let's try to build it. Looks like it's building. Okay, so this should all work as before. However, what we want to return now is probably another gray image. Another gray image. So let's return the gray copy. All right. And then here where we start the job, we're going to say whatever. Let's just return self.run build job, and this actually doesn't have to be mutable. Maybe that's going to help something, and I'm worried that if we can even do this, but let's just try it. So we take the reference copy, and that seems to work. All right, now we just need to change this to actually return not an integer, but a gray image. And I'm thinking that it's time to just import that. So using it so many times. And we can get rid of it here and here. Okay. First borrow. All right, so we cannot do this, and the reason is because it's trying to borrow self, which I wonder if we can say that that's okay. And we say like implement send for app unsafe. Okay, it's a lifetime thing, so let's not do it like that. But this function actually doesn't use any information from self, so we can put it out somewhere else. Maybe let's even make a, like, here we have some functions, right? Some compute functions. Get rid of that, and we're going to say use image gray image, and we need to include it. Let's mark it like that. So we have to say mod compute, and we have to use std thread and use std time duration just for the testing. And let's scale it up to 5, and I think that is now working. So down here, we get rid of that, and we say, okay, it's that function called compute module, and it's a private function, great. So we have to say it is actually public. It's public, and here, let's also take the context now. Context. Because when the job is finished, we want to change what the image that's displayed, and we did it this way. So here we can say just result, and how about let? How about self.image replace with this thing? Okay, and finally, when we check the job here, we actually need to get the context because it is potentially updating GPU textures and so on. So let's try to run that. And reload, and nothing is happening right away. We can still interact with the UI, but once it's done, the displayed image is updated, so it's working perfectly. Let's now try to remove the fake sleep and see how bad it is. If like creating the threads and so on is creating too much of an overhead. So it should be run. And no, it doesn't seem, there's no noticeable difference. So I think that is great. And yeah, I think that's going to do it for this video. So I will see you in the next one.